morning, everyone. We're Team One, and we have given the requirements. We tried to build a game. So the game that we have is called Junction, as you can see. And we believe that if you do not understand the traffic, then you may always be late. You can't always change things and how the traffic flows, but maybe you can do something sometimes. So the overall view of and summary of our game is shown. So we chose traffic as a game theme because we feel it's relatable to everyone, whether you're in first year or you're in your final year. So our game consists of puzzles that test the player's logical problem-solving skills. So the game logic is that we have the number of cars from one road as an input and the number of cars to various roads as an output. So the goal is for you to split the cars across the various roads and conjunctions to get the required numbers of cars at the end, which is shown on the diagram, right, where we have 5 cars and we split them into 2 and 3. So the scoring mechanism that we use is a plain pass or a fade. So how do we do that? Well, we have different levels. So level 1, which is a little bit simple compared to level 2. So the player is able to draw the roads and the conjunctions and just configure the routes so the cars can split to the required number and get the output. So in level 2, we have an intense situation where we have the roads and conjunctions built for you. So you have to specify the number of cars to exit from each junction. So based on the requirements that we had, we testing for problem-solving skills, some conceptual understanding of programming principles, because we figured out that the requirement was that if you're in metric, there's a chance that you've never seen code and you've never coded before. So we tried to include those principles, such as having functions linking inputs to outputs in our game. So we also have loops where we can also test for loops in terms of allowing the player to set the numbers that can loop through and allow the cars to continuously pass through conjunctions. And we can also test for if statements in terms of how the player decides how to split the cars at conjunctions. So this is the part that everybody's waiting for, and we're excited to show you our demo. And afterwards, Enemin will also share with us the areas for further development on our game. Thank you.
Okay, so hello everyone. My name is Gernie Visser. I'm now a second year IT student at the NWU. And yeah, okay, so this is the first level. This level is basically here to explain the how the different pieces in this game works and how it interacts. So Sipe, can you just quickly... Okay, wait, let me start here. So the red circle you see there at the left, that is the input road. So somehow we need to split the amount of cars that come in from the input road to all the output roads. And as you can see, it's a bit small now on the screen, but the input road, the red one, there's a number on there. So that indicates the amount of cars that will be entering from the red road. And then on the blue output cells, there's also numbers. That is how many cars should end up at each input road. End node. So yeah, the challenge of this game is to split the cars up so that the correct amount of cars end up at each end road. So just quickly show them there how you can create roads. So this is basically how we can create roads. But now, obviously, we need to split the traffic that is driving on this road. So to do that, we've added conjunctions. So that is how a conjunction looks like. And a conjunction will then split cars into all the adjacent roads connecting to it. So yeah, I think... Okay, we're just gonna set up a simple demo here just to show the concept of how the game items are working. You need to add a second row to the conjunction. The input for the game currently is still a bit clunky. That needs to be upgraded quite a bit. And then just the inputs, just bring that into the other side of the conjunction. Perfect. Okay, so now once you have created the solution that you think is correct. You can run a simulation. So if you run the simulation, the cars will actually start driving from the red node, from the left side of the screen to the right side of the screen on the road. So we can see that happening now. There's the first car. It's coming in, it's driving on the road. And then this current conjunction just splits the cars 50-50 to each side of the adjacent roads. So as we see now, all of the cars that is coming in will just be split equally between those two cells. But this is obviously an incorrect solution because the other cells are not getting any traffic. So one of the requirements for this project was we need to make automated marking. We want a system so that they can automatically mark and just mark if a level is completed correctly. So we have implemented that as well. So if you just press that button, it just takes a while, this function. It's a bit, but anyway, the grid turns red, and that is just how we indicate at this stage that the current solution is incorrect. So we can go back now and we can change our roads and try a different configuration, and then we can run the simulation again. So we have cheated a bit, and in the second tab, we have created the first level, and now we're going to show you a correct solution for this problem, how to split the cars correctly so that the correct amount of cars go to each shell. This computer is struggling a bit. Okay, but now we're going to run the simulation and the car is going to start driving on the road and then, okay, you just ran the simulation now. Okay, so the simulation has just been run, the check simulation function or button has been pressed and the grid turns green, so this means that this current configuration is correct. So this is the first level where you only have this conjunctions that splits the cars 50-50 and you have to build your own road infrastructure. So now we have a second example of a level 2 level. Okay, this is just a solution. Oh no, okay. But I'm going to give over here to Sipe to explain the second level.
So my name is Sipe Teto. I'm a third year computer science student at VETS. So I'm going to explain to you how the level 2 works. So we wanted to increase the level of difficulty from the first level. So for level 2, the user is given the completed infrastructure and they are supposed to only change the rules of the conjunctions, how the conjunctions split the cars that are coming from the input roads. So currently this is an incorrect solution. So when you try to just run the simulation, just spit it up. Okay, it'll take a while because 43 cars, yeah. Okay. Okay, so the user is also given the ability to pause the simulation at any point in time, then continue it afterwards. We just wait for the cars to reach the end. Okay. Okay, let me just pause and then run check solution. Yeah, so the cells turn red. That means the solution is incorrect. So the user can also change the values that you see here. So by selecting the conjunction and then say you want the value 2 for the top. So we'll type 2 and then click the top button, and then the value changes to 2. And then say you want 5 for bottom, and then you do the same thing for the bottom. So now the rules have been changed. So now when the cars come from the input road, 2 cars go up and then 5 cars go down. Yeah. So this is the correct solution for this level. And then let me see. Okay. What was the solution here?
So the last one is 5 and 3.
Okay. Yeah. So 5 top and bottom 3. Yeah. So when we run check solution, it should be correct. Yes. So the cells turn green, so it's correct. So yeah, that's basically the second level. The user can also navigate between the different levels at any point in time. So yeah, that's.
So further developments that we wanted to add is we wanted to add a block where you can actually add coding. So where you can actually code the conjunctions itself, because at the moment we only give the player the opportunity to change the numbers of the conjunctions. We eventually want to let them code the conjunction blocks themselves and give them other rules maybe. So at the moment we're just splitting them in certain numbers. Another thing we want to do is automatic generating and marking of levels. So at the moment, what you need to do is you need to kind of hard code or specify the setup for each level. So we would like the computer to generate, or we would write like a system that generates a puzzle and checks it, so that a person doesn't have to do that. And then obviously we want easier usability and upgraded visuals. So we would like the car to actually look like a car and the road to actually look like a road. So those things, the visuals we want to make, and we want to upgrade. And yeah, the text boxes aren't ideal, so we would like to make the user interface a bit better. And then another point, just that one, it's not on the slide, but what I just want to add is the scoring. So the scoring at the moment is pass or fail, but our original idea was, and we only have 2 levels at the moment, but our idea from the start is that we want to have many levels, say up to 20, for example, because our scoring is just pass or fail. So what we want to do is we want to grade the levels from easy to difficult, and then the player has a set amount of time in which to complete the levels. You get more marks for a more difficult level, say for level 20, and less marks for an easier level. And in that way, we want to get a mark at the end of the day for a player to assess his skill based on, if he did more difficult problems, he'll get a higher high mark, and less difficult problems, he'll get a lower mark. If you completed everything, you'll obviously get full marks. Correctly, I mean now. Yes, and thank you. That is everything we want to do for further development. Any questions?